Welcome everybody. Just a quick note on housekeeping. We're doing this a little bit different than the typical webinar. We are doing this in meeting style. So we try to resemble as much as possible the real physical event. This means mute yourself, please. To ask questions, you have two options. You can type in chat window your question or wait until the end, unmute yourself, raise a hand and turn on camera if you like, and speak directly to our presenter. Again, mute yourself for the time being. Type in questions as you like, and you can ask questions in person after raising your hand, after the speaker has completed his presentation. Thank you. So I have a great pleasure of introducing our today's speaker. First, big thank you to our marketing team, to VCU Cybersecurity Center support, to CCI sponsor, CCI Center of Virginia Node, and CCI Hub. And last but not least, my three students that will be supporting this, managing Zoom, along with IT, Mark Jenkins. My students' names are Christo, Cheturi, and Vasily. So thank you all. Very briefly, I will let Wayne speak about great things he's doing. I will just mention that he's a technical director of the CyberCore Integration Center. Beautiful buildings. I had a pleasure of Wayne actually giving me a tour about a year and a half ago. Wayne is also Chief Technology Officer of National Homeland Security at Idaho National Lab. And something that we are really excited about is Chief R&D Officer of CyManII, public-private entity of 110 million and counting. Again, for our postdocs, for our future students graduating soon, CyberCore and opportunities for internship are wonderful at INL. Wink, wink, watch out, and please do contact Wayne after the talk. Thank you very much. Over to Wayne.
Okay, I think I have my screen up now. So thank you, Milos. One update is that as I've been collecting different roles and responsibilities, I've moved on from the technical directorship of the CyberCore Integration Center, but I do still have a heavily focused job as I've moved up for CTO across our cyber, our nuclear nonproliferation, and our defense systems lines. I have two parts to this presentation. The first of which is INL in general and heavily focused on our cyber physical activities, but also on the Cyber Manufacturing Innovation Institute, which VCU and a number of partners have joined, and we very much appreciate the contributions that your folks' team has had as we have brought this institute to the team that we'll describe. So briefly, oops, looks like, there we go. All right. So INL, in the lab system, there are three tribes of research laboratories in the DOE system. The first is the sort of the nuclear weapons labs, the NNSA labs, the science labs, and the applied energy labs. INL is one of the applied energy labs. We lead the nuclear energy vision for the nation, but we also have a pretty heavy critical infrastructure mission that we'll talk more about as we get through it. Independent of org charts, we have 5 long-term research initiatives. I won't talk about most of them in detail, but just briefly on the nuclear energy side, if you haven't tracked where we're going with these new forms of advanced reactors, in particular microreactors, in which you're eliminating the liquid coolants. Effectively, it looks like a fission battery. Sometimes there's a power conversion that, that is a variety of different things, including even infrared type solar cells harvesting the heat directly from the fission battery. There are some really interesting concepts going on in that. And microreactors at less than 10 megawatt scale have a lot of different distribution mechanisms that you can start using them in distributed energy or industrial aspects. So there's a great deal of that goes on in the laboratory, particularly in how you close the fuel cycle with these fission batteries that sometimes are actually fast reactors that are burning the long-term waste. In the center there is the advanced integrated energy systems. This is premised on the fact that we have a mixture of thermal and electric things going on for our various uses of energy. And how do we do that in a much more optimized way? And this is particularly important in some of our manufacturing process environments or alternative uses of coals and high temperature loops that you might find in reactor side of things. On the far left or far right is our cyber and physical systems initiative, which we'll talk in more detail. It influences a lot of these different pillars in different ways, including some of our manufacturing initiatives and our nuclear cyber initiatives. But we'll talk specifically about the cyber physical and the control system cybersecurity work that's pretty influential in CyManII and just our infrastructure work in general. For those not familiar with the Idaho National Lab, we have a research campus there in the that's described in a picture in the lower right. But one of the major assets that we have that is unique within the national security complex is that this 900 square mile range where our critical infrastructure test range resides has a variety of industry and large scale test beds that are integrated into our research cycle. And so from our nuclear reactor experimentation history, we very much believe in surgical testing and validation with heavy validation at full scale that then feeds your models rapidly so that you can more rapidly learn and innovate. And a lot of these reactor designs that I talked about are based off of the fact that we gathered all that data from lots of different tests over the years, and we're able to build the models and refine the models and do the physics in the compute cycle, as opposed to repeated expensive cycles on the range. We're doing the same thing across wireless systems with full-scale 4G and 5G test beds, non-standalone networks at the moment. Power grid test beds with entire meshes and distribution systems and transmission systems, instrumented both for the commercial control side of things and for the experiment side, and a myriad of other ranges listed there that are interesting. The explosive folks, there's only so many ranges across the US that you can explode 20,000 pounds TNT equivalent as you're looking at structural issues and armaments. So it's an asset that we're pretty proud of from a national security sense, and does support a fair amount of our infrastructure class control systems work. As an example, I talked about the power bid test bed and that full scale aspects. There's pictures there about the distribution range, the transmission, linking to our mod and sim and our hardware in the loop. So if each one of those test beds to varying degrees is rigged something like that. So focusing more on the control systems and the cybersecurity challenges with infrastructure. For those that are working in this domain, most of us are convinced that the current measure countermeasure approach is not scalable. Our adversaries are able to find vulnerabilities faster than we are finding our own latent vulnerabilities. And you find in many cases, particularly in the embedded domain, sometimes we're patching high-level software and we're implementing it in compiler and architecture matches that are opening more vulnerabilities than we're closing with the patch cycle. And there's some interesting studies that have been shown in some domains on that. So basically, and this is a lab view, and it might also be compatible with a university view, we really think that we have to spend some time on the more fundamental challenges of how you secure these systems, and secure them not just in a bits and bytes standpoint, but recognizing the realities of the full engineering that's going into the physics of these systems, and use all of those tools to bear as we are trying to secure these against high consequence events. When taking these approaches, we're biased by our range information, but we want to be able to support the rapid deployment and testing and experimentation in order to learn how these things interact at scale in order to more rapidly deploy them. And then the final challenge, of course, in cybersecurity is just the technical expertise. I will say that a portion of that is because we've embraced a more operational and responsive view of cybersecurity. Part of the challenge is that we have such a large need for this technical supply because we're building a lot of cyber firemen that are responding, as opposed to the designers that design fire code rated sheetrock, right? The cyber equivalents and fireproof houses and fire codes that prevent the fire from spreading from a house to an entire city, state buildings. And so if we start shifting our focus more to those fundamentals and start making it cheap and easy to deploy secure systems, as opposed to more responsive technologies, we might be able to shift the balance of what's going on relative to the expertise supply line. So that's why, Milos mentioned the CyberCore Integration Center, which was built as an integration park, research and education park across the different labs and agencies that we're already partnered with, and fuse them with the large scale assets that we have out there, so we can try to rebalance our, for lack of a better word, research portfolio, so it's not all consuming on the urgent mitigations of the day, but focus some more on the transformational research that we're going to need in order to get ahead of the curves on these vulnerability services and adversary tactics. Here's a view of how we sometimes bin the problem and the spectrum of technologies and disciplines that can be required. You can have other views of it, but if you look on the left, we very much view that you can't look at the engineering side in its own cylinder. Too often we're applying the digital technologies late in the cycle of the control loop and not thinking about how we're changing our engineering principles or changing how our design software is working to incorporate how we're going to do things as we apply the digital controls later. And since there's a lot of modern sim and computer-based design that's going on the engineering cycle itself, instead of just harvesting it into digital twins monitoring of your system already deployed, how do we incorporate these cyber design and risk trade-off tools early in the engineering cycle? On the right side is more about getting to a more adequate formalism in how we're building these embedded technologies and the bits and bytes and the communications that go on. That's certainly important. And so the premise is that as we look at these more automated and resilient systems, that we don't just want to look at it in terms of a response cycle of what we're seeing on the bits and bytes on the line. We really want to look at the larger engineered behaviors in the system. And then when you develop your situational awareness, when you develop some of your security mechanisms, even in the embedded systems, you kind of have a more holistic picture. And so that's the premise that we have. There's other ways to slice it, but it's a way that we sometimes divide it to try to bring back to the engineering fundamentals. I will mention that we also have a new book that's released based on some of these engineering principles. It's referred to as countering cyber-enabled sabotage of infrastructure systems. And at least the assessment approach for existing systems is referred to as consequence-driven cyber-informed engineering. I won't go through all those phases, but effectively it's driving the market to recognize in the beginning and the engineered functions that you're trying to deploy, the interrelationship between the digital technologies that you're deploying and how you manage the consequences that you're trying to avoid. So it's almost like a safety-driven approach, if you will, as you go through that digital life cycle. And the book goes through and describes it in sort of a mixture of ways. The front end of it is meant more for managers. The back end of it does dive into a little bit more deeper. So I don't know how to describe it as, it's not quite a textbook, but it's not quite a manager's book either. It's a little bit of a hybrid. There we go. I'll mention that in terms of infrastructure scale beyond the control systems loop, we're one of the largest labs executing Department of Homeland Security work. A lot of that is at sort of regional and beyond utility scale infrastructure, utilities on utilities, and the interplay between water and power and other distribution mechanisms and communications. As part of that, there's a very large training group that we've set up, as well as we're the sort of the first technical tier that DHS, the formerly known as ICS CERT, hunt and incident response teams that go out and respond to some of the malware that's hitting the infrastructure right now. From a resilience standpoint, for those that have worked with Milos and Craig Rieger, we host an annual resilience week that's expanded well beyond control systems and critical infrastructure. Last year it was virtually hosted in a way in Salt Lake City. And so I would encourage you, if you have an interest in resilience topics, not just on the control loop, but on infrastructure scale and regional responses, that you look into that. And Milos has some history there. I'm getting towards the end of my INL side of the slides because I want to spend some time on the Cyber Manufacturing Institute that VCU is a partner on. But I do want to mention that we've recently stood up the Wireless Security Institute to fuse some of the research that was going on at INL with the full-scale cellular test range that we have out there. That test range is a full-up tier 1 switching center. It's isolated from the public telephone network. It has its own call generators, has multiple generations of technologies, and it's instrumented with not just the instrumentation that you need to control and re-rig the cells and the control channels at will, but every signaling line, every data line, every RF emission is monitored and torn down at its essence in terms of a protocol. So it's a very rich experimentation system that now has the first sets of 5G equipment, the non-standalone versions of it being deployed as that standard is evolving. And those that are tracking the industry mythology with how 5G is deployed will recognize that there are portions of that standard that is being rolled out, but there's certainly a lot of other portions of the network and the security layers of the standard that are still in process. From an internship and academic partnerships, there's a variety of opportunities, not just for students on internships, for the strategic national partnerships we have, or the contract partners that we have with the National University Consortium, or even our regional Idaho partners. We have joint appointments like Milos that work hand in hand with our researchers on specific projects. We also have visiting faculty positions, postdocs, and other things. And if you go to our academic partnerships website, you'll find a lot more information on there. Our approach is very programmatic. If you haven't done a research exchange with a laboratory, we tend to be very focused on the high priority national challenges. And our goal is to try to expose you with a very hands-on collaboration that kind of influences the creativity and the types of general exploration programs that you often find in NSF grants and universities, so that you understand where you can have the highest impact relative to some of the harder challenges on national priorities. And that's our goal when we try to align both professors and students. Just some stats in terms of the internship program. We did manage to pull off over 400 interns last year remotely. That was, or this year, depending on how you want to count it. that was definitely a challenge, but we try to provide a mixture of experiences, not just for the direct research programs, but we have a variety of other enrichment activities and even regional explorations. So there's some additional information there. So I'm going to shift gears from the INL side of the slides, but before I do, is there any questions on the INL side that I've presented, or do you want to wait till the end to answer questions?
Perhaps we wait till the end and then we'll go ahead.
Okay, so shifting to the CyManII side of it. So the Cyber Manufacturing Innovation Institute is an institute that is funded as a result of a Department of Energy FOA or call to assemble an institute that can provide cybersecurity in such a fashion that will be able to deploy energy efficient digital technologies to advanced manufacturing. And so there are about 16 of these institutes nationwide. Approximately 9 of them are funded by Department of Defense, 1 of them Department of Commerce, and about 5 of them from the Department of Energy. And I forget where one of the other 16th institute is funded. But these institutes, their purpose is to advance technology to industry through an aggressive form of consortium and partnerships. And so if you look at CyManII's vision, the challenge we're taking on and recognizing that this institute is a little bit lower TRL than some of the others. We're a TRL 2 through 6. So the technology readiness levels from 1 to 10, using your favorite DoD or DOE or NASA scale, we're a little bit more basic than some of the more applied institutes in the manufacturing system that are typically 6 or 7 to 9. But part of our vision is to try to transform cybersecurity into something that is pervasive, unobtrusive, resilient, and very economical deploy. And so we can achieve energy efficient manufacturing with this sort of pure approach towards cybersecurity, getting to the fundamentals of not just the bits and bytes, but some of the energy signatures and physical signatures going on. So we refer to that as Epsilon Pure. The team that we've assembled for this, that includes VCU, we're still signing membership agreements and signing folks on. So the Institute was launched silently in the fall, but the membership agreements were finalized by the Department of Energy in December. And so somewhere about January and February, some of the folks that were on the original proposal team, as well as other industry partners that are interested in joining, have been signing up as part of the consortium. Just with the labs and the universities that we have assembled to date, we have a pretty impressive collection of assets to kind of not just look at the research side of the problem, but provide an environment where we can, on an accelerated basis, try to test some of those solutions so they can be more easily deployed and transferred to other institutes. The other thing I'll mention is that one of the partners that we have is the National Center for Manufacturing Sciences, or NCMS. They run their own sets of research calls, very applied typically, but they have access to over 600 industrial partners as part of their management structure. So this team that was led by UTSA in San Antonio and assembled the 3 key labs when you're trying to address ICS automation security, supply chain risk with Sandia, and manufacturing interest with Oak Ridge is pretty powerful. And we're pretty excited to have the collaboration with a lot of different partners, and particularly Milos and others at VCU. So here's the foundational tasks as represented in our integrated technical approach. And I apologize, there's some acronyms on this diagram, but I'll go through it a little. For Department of Energy institutes, all institutes, but particularly Department of Energy institutes, they really expect a lot of focus on analyzing the gaps and challenges and creating a national research roadmap that first year of operation. And so as we're bringing in new members, in the March and April timeframes, you're going to see some early drafts of the research roadmap that we're proposing, and we'll be starting a series of workshops to review those with national experts from industry, other institutes, and that as we form what the agenda should be for the Institute over the next 5 years, and appropriately investing that $70 million worth of DOE funds and presently $41 million worth of mats from our industry and university partners. And so the end of this year, we'll be issuing RFP calls against that roadmap to start working on some of these challenges. Now, this roadmap and this RFP will evolve annually as we get deeper into the problem and deeper insights based on the research and further engagements with industry. But the results of that will bin into at least 4 major task areas represented by those acronyms. The first of which, labeled number 3, is secure manufacturing architecture. We'll discuss briefly what this means, but basically what this is creating that new security architecture that unifies both automation and supply chain aspects and looks at the challenge different from beyond just the bits and bytes. And we want to be able to address this because in order to truly address some of these challenges through the full digital engineering lifecycle, we really need to think about security beyond just the bits and bytes, but also provide the tools that make it easier for people to develop the secure systems and secure sensors and secure communications. The middle sort of sphere, if you will, SRDI, is the shared research and development infrastructure. So we have a lot of assets. The vision is to be able to have, in a federated fashion, access to those assets, both virtual and physical, to be able to advance these new techniques and architectures we're developing with SMA and validate the security of them with a variety of processes, including our Coordinated Vulnerability Awareness Program, or CVA. And so part of the goal is getting to a level of formalism in this design and testing process that more and more we're validating in advance of deployment, so we have a proactive look towards vulnerability discovery and doing a lot less vulnerability discovery and acknowledgement after it is deployed. Now, the bottom foundational task is called Trustworks. That is our outreach arm in order to have a transformational impact to the manufacturing sector. We need an ability to educate folks on the issues, the technologies, and be able to provide access to industry players so they can have early insights into where the technology is going and how it's going to be integrating into their plant. So that's kind of the foundational tasks, and they're very interrelated. The one other acronym on there that's not a foundational task, but is a foundational concept for those that are familiar with measurement and validation techniques in industry in order to look at your energy consumption in your plant and manage those consumptions and signatures. If you're taking it to another level where we have concepts of embodied energy across the entire part or process that's being manufactured, and doing that in a secure fashion as you're feeding it into your optimization models, that's what we're referring to as CEQ or cyber secure energy quantification. So that's the overall approach. To cover each one of these in a little bit more detail, from the secure manufacturing architecture, we have 3 high-level sets of principles that we're working on. The first is we have an integrated view or an integrated model of automation and supply chain. And so what I mean by that is that if you look at the classic ISA 99 or Purdue models of automation, there's still a fundamental assumption, especially at the lower layers, that we have trusted control signals between our sensors and actuators, and that our perimeter defenses are what we're using in order to prevent a lot of malicious cyber activities. Now, there's other things that folks are introducing with IoT and data-centric models and behavior of some of of what's going on in control loop, whether it's digital twins at a scale or some other techniques at a lower level. But fundamentally, a lot of these things that are going on the automation floor are loaded based on the supply chain design that's going on. So for example, if we're building a variable speed motor that's going to be going into a steel plant, that's a custom setup that is designed for that particular plant. And the digital electronics in that controller are the design files for it, for the manufacturing of it, are exchanged over common digital formats, right? Sometimes directly from the engineering design files, sometimes there's other translations, and there's all sorts of examples of this. And so if we don't have a secure view across the entire supply chain, and we're just trying to various forms of perimeter defense on the automation or behavior type aspects just on the automation controller floor, we don't have a full picture of it. And we're probably going to be playing a little bit of a whack-a-mole as we chase this problem. The second principle is that we want this framework, besides integrate automation and supply chain concepts, to be able to fuse concepts of physical signatures, energy signatures, even embodied energy for energy tracking, as well as the bits and bytes into the various forms of identity and activity validation that's going on within the automation floor. So there are potential concepts for these multi-dimensional passports, various automation and supply chain relevant ledgers. Those are the types of concepts that get discussed. But aside from the implementation, the approach is that we unify automation and supply chain, and that we have this multi-domain aspects and concepts according to identity and activities. And part of this will permit us, hopefully, to overlay these techniques in parallel or on top of some legacy approaches to control as the secure manufacturing architecture becomes more mature and become more relevant and closer to the control loop. The third principle on the secure manufacturing architecture is trying to get to some level of adequate, agile, and consequential formalism. Now, at some levels, we can use targeted formal methods or similar approaches as you try to validate architectural designs and some forms of implementation. When you go through the build chain, it's maybe too complex, or definitely too complex presently, to apply true formal methods through all elements of generating binary code that gets executed in the processor. However, there are other forms of evidential basis and machine learning and other design validation techniques, depending on where you're at in the build process, that if we fuse with some of the successful formal methods that are coming out of DARPA programs, Software Engineering Institute, other places, what we're trying to do is, through that full build process, increase the level of formalism and confidence that we're implementing the security mechanisms that we think we are. Part of this is developing an agility that we presently are borrowing from other software principles, the CI/CD processes, which are very common in certainly cloud and other processes, but do not presently have a manufacturing context for a variety of reasons. There's a lot of challenges associated with agile methods in cyber physical systems in general and manufacturing plant floors in general. But stepping back to one of the principles that folks sometimes forget about CI/CD is trying to get to small, provable changes that are very well tested and often automatically tested as part of the build process. And so those principles, as we're trying to implement this more holistic view of cross-domain security, across the digital life cycle and supply chain, incorporating those principles into the validation of what we're producing is very important. So this is an extremely high-level view of where SMA is going. We have a series of workshops and road mapping activities that really is tearing through this in a much finer grained sense. And until that roadmap is finalized, probably can't really adequately describe whether this is 100% on target or some of the details. But this is the approach that we're using as we're discussing it with our industry and academic partners in our road mapping sessions. So next, the shared research and development infrastructure. Basically it's where we're developing and validating our secure manufacturing architecture, and where we are building and deploying and using those validation tools that apply some sense of formalism to the things that we're building, and doing proactive design vetting and vulnerability discovery. It's also, given our integrated technical approach, we will use these modules that we use in research and validation, start deploying those to the Trustworks outreach so our industry players can get a view of technology from the Trustworks system, accessing the core labs, accessing the tool sets that we're doing, so that we can either evolve those tool sets or prepare the workforce and the industries for these new technologies that are going to be deployed. So the idea is being able to have this federated system in which we can securely dedicate the appropriate slices of connectivity between equipment and simulations and software and tools to be able to support the researchers that are in our environment. We're presently hosting it in various FedRAMP and government secure systems. So there is a vetting process for who and how we will let assets and people on this system. Finally, Trustworks. It's both our market transformation as well as our long-term sustainability model. For those familiar with the institutes, most of the institutes have to achieve some level of sustainability after 5 years, after the first infusion of funds from, in this case, the Department of Energy. Some of the DoD institutes actually transform themselves to become program offices. The Department of Energy model is a little bit more industry self-sustaining. So Trustworks becomes both the outreach and the sustainability model as we continue to work on those science challenges, on the hard challenges, post 5-year roadmap, assist folks and vendors incorporate those fundamental technologies into their own product lines through the secure wing of Trustworks, and provide the educational access associated with how you address the gaps and ingest these technologies and incorporate them in your plant floor. I keep forgetting. Here we go. The overall institute's goals are pretty aggressive. As cybersecurity researchers, hopefully that 1 trillion number is standing out to you. That is vulnerability instances mitigated. This always leads to pretty good intellectual debate, but the key word is instances, and the key concept is understanding that there are latent vulnerabilities that just because you aren't aware of them, they still exist. And even though it's inexact, there are methods to estimate based as we evolve our security profile and address them in both architectural design and implementation, and more proactive and not just reactive closing of classes of vulnerabilities. The key is that proactive nature and actually getting to vulnerability instances. We wanted to set the bar high for a variety of reasons, but instances is also key because if we just identify vulnerabilities and they aren't actually, the closures and mitigations are not deployed, we're really not having the impact in terms of the cybersecurity posture that we really want. And so that's part of a key part of it. Now, as part of deploying these new security technologies and digital technologies, we're going to aid in the efficiencies associated with manufacturing. We've gone through the projections on market penetrations that we need by sector, and on average, after 5 years, we're looking at about an 8% market penetration on some of the key energy consuming sectors. And with that, there's a lot of money and energy sitting on the table. And then from a workforce outreach, we want to be able to train folks on these new cybersecurity principles. We may have to address some gaps in basic cybersecurity principles and hygiene, but our goal with the Department of Energy is to have trained 1 million manufacturing workers at the end of 5 years as part of our Trustworks outreach. So that's a summary of CyManII and a little bit of INL. Both of them have internship opportunities. The internship opportunities on CyManII are clearly with a lot of the laboratories that are involved, Idaho, Sandia, Oak Ridge. But as we're gaining some of our industry partners, we're working what that rotational exchange would be between the laboratories, industry, and universities. And clearly, in the initial stages of operation, we'll have to continue some remote work, until we get past some of the COVID challenges. Hopefully that was helpful. I know it was a high level and some of the slides were fast, but I think I'll turn it over to Q&A now. And maybe I will try to bring up the chat so I can see what's going on there.
Wonderful. Thank you very much, Wayne. And thank you very much for perfect timing. We have a little over 15 minutes for Q&A. We have a couple of questions in the chat window. The first one, how do these efforts, assuming related to CyManII, compare to those in other countries, specifically advanced economies like Germany, Korea? I will generalize it to Asia and Europe.
Yeah, so there's a lot of advanced manufacturing institutes, if I can use that word, overseas, international. These institutes are dedicated towards the reinvigoration of U.S. manufacturing. They're congressionally mandated, and that's why there's a heavy bias towards U.S. Companies, if you will. Now, the reality of this market is, like many markets, is that there is a huge international presence of not just controllers, but manufacturing technologies. So in my mind, I've seen other institutes that are very advanced on the different types of manufacturing techniques overseas. I've not seen sort of the same cyber equivalent, if you will, dedicated to manufacturing internationally. Now, there are all other cyber institutes clearly internationally.
Thank you. So here's another question. Are there simulation tools or models or frameworks available to study these problems? It's the question is coming from John. He's referencing Ncms. Ncms stands for Transportation and Analysis Simulation System. I will also let John speak if you prefer to do so.
No, I was just when you talked about studying the combined frameworks of manufacturing and transportation and studying them collectively, I was just wondering what sort of tools are available. Are you developing stuff off from scratch, or are you using off-the-shelf tools? And one that comes to mind is a tool that's been developed at Argonne National Labs, and that's the Ncms framework.
So I've not personally looked at the transportation side of supply chain or some of the modeling tools there, but in general, there are several frameworks and tools out there. I'm most familiar with the control systems and cyber simulations, some of the Scepter models, and some of the tool sets that have been set up academically at Purdue and other places. You also have the process models that are both used in the design phase and to some extent into the digital twin and digital ghost side of things. And there's a lot of different sector specific things, right? There are steel mill plant mod and sim tools. There are process tools that are used in additive manufacturing and other things. And the idea is that since these tools more and more are not just designing the machines or the process, but they're being incorporated as part of the control and machine control strategy as part of the manufacturing, that there's some other techniques and other things that we can do from a cybersecurity sense and a process efficiency sense that is useful. The transportation side is not my domain, but as we prioritize where we think the biggest challenges are that we want to address in the road mapping process, certainly as transportation-oriented supply chain aspects come up, we may have to look at some of these things. So, and that's part of what we expect to learn as we add more team members on. Every month or two, we indoctrinate whole series of new partners. I think Milos was on one of the initial indoctrinations already.
Thank you, Wayne. You are having a shout out from Tennessee Tech. They're saying that they joined from there, and they're happy to be part of this discussion. Now, going back to INL, we're getting questions on internships, how to apply, how do we go about this? Can you give us a few more details?
So there's I think the simple website is something like inl.gov/careers. It was in my presentation. Basically, the process is whether it's an internship, one of our graduate fellowships, our postdocs, you apply online there. There's a series of about a dozen posts that are generic. Even though there's only a dozen job categories you apply to, there's a series of questions that you answer. And our laboratory actually generates more specific requirements or needs that we're looking for, and they match it against that database. So if you apply to a cybersecurity posting, there might be a couple depending on how we're trying to do the screening questions. You apply to one post, everybody has access based on the filters I write. So I could be in a manufacturing side of things and decide that I need this type of researcher with these type of cyber skills. I don't have to create a new posting. I generate my requirements and it's pulled from that database. Now, the other thing that we rely heavily on is we want to be able to take recommendations, particularly from our faculty partners, in particularly our joint appointments, who know these students, know the focus, are familiar with the broad sets of research. And so when I see, when the PMs see a resume from an institution that we know we have a trusted professor or a joint appointment, we'll kind of take their recommendations both from the candidate and not just in a standpoint of, is this a good candidate, but where are the gaps of this candidate? If we're trying to look at enriching this person's career or aligning to their particular research, let's have that conversation, because although it's harder up front, when we can align the research interests and the thesis interests for the, and dissertations of the graduate students with the high impact challenges we're working on our programs, that makes for a lot of better resonance between our funding mechanisms and the impact of the university research going on. Was that helpful, or did I dodge the question?
Thank you, Wayne. And Eleanor also posted in chat the link to internships. So please go click and do apply. Staying on topic of INL, there's a few questions relative to current focuses of INL Wireless Security Institute. This is coming from our professors working in wireless arena. So current focus of Wireless Security Institute, the new one.
So the current focus is we have historically our research is focused at INL on dynamic spectrum issues and spectrum sharing and security approaches that kind of look at how you build security in based on the physics of what's going on in the waveform channel. So that's been a particular historical focus. Our cybersecurity engineers have been separate from wireless, have been looking at protocol level and architectural flaws that translate, down to even binary levels. And so over the last few years, we have fused those pools of expertise. And so the focus is recognizing that there are lots of high-level principles and even some initial standards on what 5G is going to implement. When you look at the nature of it, where some things are implemented in hardware, many things are implemented in software, it's very important how you structure not just the architecture, but the protocols and the implementation. And then there's this other aspect of how do you validate that you have the security in the slice that you think you have. Most of these standards are actually optional across the vendors right now. And so if you think you have this level of security of assurance, how do you validate that for the particular sensor or level of security service that you're trying to expect? So those are the types of things that we tend to look at. But more broadly, we've been hosting a series of workshops in partnerships with universities and industry. So we have Qualcomm partnerships. We have the CTOs from DoD, DOE, and DHS all participating. And I think if you go to the Wireless Security Institute website, you'll see some proceedings there that have a really nice set of depth in terms of what the real challenges with 5G security is and where they need some of the researchers focusing. So I'd encourage going to those transactions, and there's also a point of contact there that can describe in more detail some of the focus.
Thank you, Wayne. So talking about INL testbeds, and I'll preface your response by saying you can drive for hours around Idaho Falls and not be able to visit all of the testbeds. One of the questions is relative to available data sets. Are there some available data sets coming from these, and how do we get those?
Yeah, this question always comes up. And the bottom line answer is, although we have more flexibility than, say, if you try to get data from like a power utility, there's all sorts of filtering that has to go on to remove IP addresses and other things. Or you have to sign some very stringent NDAs and prove that you're protecting some of that data and configurations, to the comfort level of industry. Since we operate our own systems, we're a little bit lighter on that, but we don't post the data freely, on a website or open access. We do have our university partners that are engaged with us on a particular program. They can get access to that data. But what we found is, and maybe this is an excuse that it's just hard sharing data, from these assets, particularly when we have a mixture of Department of Homeland Security work and university outreach. But truly, what we found is you need the context of what's going on in the system, right? And we're not very fond of just pure data analysis without the larger context. And so for those that are interested, I would say, let's talk about your interest areas. What type of data? What are your algorithms or your approaches that you're trying to validate? And then let's make sure that we have the right program and the right context, because otherwise we'll be feeding you data that doesn't match your needs. And so, long answer that no, it's not publicly available, but it's accessible to partners based on aligning to the programs.
That is the perfect response, and I can attest to the process of going through these, the value of those data sets, and the reason why it's done that way. We have a question from Dan Han. He is our Information Security Officer of VCU. It is interesting to see that secure manufacturing architecture is borrowing from DevOps concepts as the CI/CD pipelines and DevOps concepts is typically derived from advanced manufacturing concepts. With this said, what would be the desired deliverable from the Secure Manufacturing Architecture Initiative?
So can Dan speak to that question a little bit more?
Dan, go ahead.
Hey, good afternoon. First off, thank you for this very informative presentation. I was genuinely intrigued, specifically when I was looking at the secure manufacturing architecture slide, and also listening to you talk about it. I think one of the questions that I had is, looking at secure manufacturing architecture, I certainly get it. I know why it's needed, but what is the desired deliverable out of this initiative? I mean, are we going to be publishing some standards, or are there going to be technology that's going to come out of it? I guess that's a piece I wasn't very clear on. Thank you.
Yeah. So, and that's a good question. We have this debate in our initial road mapping sessions, right? The dance with standards is long and sometimes involves bruises on your head as you bang it against the wall.
Understood.
But ultimately, that can be a success measure. So what we're looking for right now is creating that framework and proof of principle that then our industry partners start engaging in an open way, right? We want to, clearly there are a lot of proprietary approaches here, but we want to be able to have an open approach that may translate to standards. It may initially be some sets of tools, and there may be some prototypical software, but we're not here to produce a new set of software in and of ourselves or by ourselves. I could envision that there will be some open source repositories or open source like repositories as we get this started. But when we're trying to transform the market, you have to have the vendors embrace it. And the vendors that we have, the big boys, the GEs, the Ciscos, the pending Lockheed Martins, they recognize that although they have their own proprietary interests in different sections, whether it's a controller or a digital twin, because of the interconnected nature of this supply chain and the nature of the small manufacturer, we have to get to some set of open standards that allow us to develop software in a different way. And different is unifying how we're loading these digital things into the controllers, unifying the physics and the energy and the bits and bytes that are going on through the design phase, and having formal validatable methods, right? And I don't want to get in a formal methods debate, but unless somebody wants to, we can take a religious discussion offline, but some level of adequate formalism that incrementally improves, with this CI/CD type concept. Does that help? I realize it's kind of fuzzy, but part of that's being defined as part of our road mapping process. And I'm sure we're going to impact standards, but it'll be evolutionary. We have people from IEC that are been participating or going to participate in our road mapping process. So that certainly is an element of the secure design lifecycle standards right now, as well as general controller and sensor security standards.
Absolutely. Thank you very much. Really appreciate it.
Thank you, Wayne. We are getting to the end of our today's talk. In a few minutes, VCU leadership will move on to close the executive session with Wayne. We have one more question that we should entertain, and that is, how do we get involved in CyManII, different working groups? Maybe just briefly, some pointers where to go and how to do that, how to go about that.
So, Milos, you're the sort of senior point of contact we're dealing with, right?
Correct. And if you can address also any possible restrictions and.
Yep. So one, Milos has been through the indoctrination. That means that you've signed some form of the membership paperwork and others. There is a process by which each institution lists the researchers that they're going to have participate on it. And there is a conflict of interest form that you fill out associated with your activities. There's a vetting process. If you're not a US citizen, foreign nationals are permitted, but there will be a vetting process, and there has to be a vetting process on your conflicts of interest. The other element to understand is most of the partners have different levels of in-kind contributions they've made. And often this is labor. And so understanding how this fits into VCU's strategy of how they're in-kinding contributing, is an important part. Now, when RFP time comes, any one of the institutions can respond with an RFP and will handle the CUIs and vettings based on new team members that you want to add, on research that you're proposing after the RFP calls. So, and I will say on the in-kind, this is full government glory in kind. So a professor that has 50% jobs probably is not going to pass the audit on, are you actually spending hours time on institute activities? And hopefully that doesn't dissuade you, but it's government rigor on that.
Thank you, Wayne. I would ask everyone to unmute their microphones and thank Wayne for the wonderful overview of some really, really hot topics. We could not have thought of better speaker than you, Wayne, to kick off our Cybersecurity Center and CCI speakers. Thank you again. And please do mark your calendars for the March 11th. We will have a next speaker. Dr. Eric Peterson will be talking about standing up large institutes. He was involved in standing up at least 3 of those between $50 and $150 million. And tomorrow, our department has Friday seminar series. Tomorrow, Dave Raymond from Virginia Cyber Range will be talking about the Cyber Range. It's a great tool for our faculties to use for teaching and research. And with this, I would thank again everyone. And Christo Vasilia Chaturi, please do move us to executive session. Thank you, everybody. Thank you one more time. Have a great rest of the day. All righty.